Hi friends, I am Shravana and welcome back to my channel Sparkling Future. Before starting with today's topic, I request all of you to subscribe to my channel and also please like, share, comment and hit the bell icon for the latest video notifications. Thank you. Friends, we will see one of the most asked interview questions today, which is the differences between RDD, Dataframe and Dataset. Before starting with today's topic, if you go to the GitHub of my folder, there is a file called YouTube videos list. Here you can find all my videos and with the link. So you can copy paste this URL in the browser and you can get the videos. So this way you can easily search the content in my channel. Thank you friends. So now going back to the topic. First we will see what is a Dataframe, what is a dataset and what is RDD in Spark. So Resilient Distributed Dataset RDD is the main abstraction of Spark Core API. It is a collection of immutable objects distributed across the cluster and can be operated in parallel. RDD offers us transformations and actions using which we can perform the functionality on the given data. And similarly, what is a data frame? Data frame is also a distributed collection of data organized into named columns. So when you talk about it, right, like conceptually we can say it as a, we can relate that as a table in relational database. And also latest Spark versions, right, it is coming up with some inbuilt optimizers. So Dataframe takes the advantages of Spark optimizers. And also using a Dataframe, they are very compatible to work with Hive, Hadoop and all that. Means that we can run Hive queries from the Spark itself. We can write the data into Hadoop. We can save a table directly. And we can read a Hive table, we can modify, we can rewrite, we can write to some data to some Hadoop location. All those things we can do using the data frame. And it mainly works on structured data. And next one is dataset. Datasets are like extension of data frame APIs, which provides type-safe, object-oriented programming interface. Dataset takes the advantage of Spark Catalyst Optimizer by exposing expression and data fields to a query planner. So this is about what is what. So next, coming to the limitations, RDD actually if you see, right, when you work on RDD, if you remember the query planning and all, there was another video which explains about the Catalyst Optimizer. If you see that, after applying all the optimizations, at the end only you will see RDDs, which means that this RDD, if you wanted to create, it will not go through that entire process. So it will not have that advantages of using the optimizers. And second one is the inferring schema. Because using RDDs we can work with unstructured, semi-structured and structured data sets. So it will not infer the schema. We have to explicitly give the schema to this using case classes. And what are the limitations of data frames? Means it doesn't support compile time safety. Means some basic errors alone it will show in the compile time. And whereas some attribute related, like the table name, column name kind of attribute errors will be shown only during the runtime. And then cannot regenerate the domain object. This you will understand very clearly with some sample code. Okay. So before going to the differences, let's see how to create each of these. So first one is, friends, I have this is Scala page, one Scala object I have created. I have defined the main method, created the Spark session, and this is the way I am creating the RDD, like spark.spark context using the parallelize method. I am taking a sample sequence of data, and when I complete this, RDD will be generated. This is one of the ways to generate the RDD. and then this is the way we can print the RDD. And now assuming that RDD is already there, now we will see how to create a data frame. So we have already created the Spark session, and there is an option called create data frame, using which we can create a data frame from one RDD. And then here I am using 2DF, and here we can give the columns, which means that here many people get confused, like it's already a data frame, why do we convert this to the 2 data frame? But actually this .2 data frame function is used for applying the column names to the data. So now if you see here, there is no column names here. So using this 2DF function, we can give these column names to this data. And if I am placing the cursor here, hope you can see this clearly. This is RDD of string comma int, which is string is this column, int is this column. So once this is created, the RDD is of type string and int. Okay. And similarly, if I place the cursor here, you can clearly see it is data frame object. Got it? So this is one of the ways to create the RDD, which is using the parallelize method, which is present in the Spark context. And we can use the same RDD, or we can, in another way we can say converting RDD to data frame is one of these ways, is this one, like Spark dot create data frame, and pass this RDD here. Okay, this where whatever RDD we already have, I am passing that RDD to here, and using this .2df I am giving the names, column names to this data, the sequence data. And df.show is the method used for showing the data frame, like in how we have used for each of println for the RDD, right? Similar way, this is the way we can use it. In the latest versions of Spark, we can convert the RDD to data frame using this method as well. For that you need to import spark.implicits. So if you see here, you are converting RDD means this one, whatever we have created in the previous step, RDD.2df. This will convert RDD to data frame. And if I place the cursor here, you can see it is of data frame. Okay. And now data frame.show is the method used for seeing the data frame contents. Now dataset, how to create a dataset from RDD, or how can we convert RDD to dataset? Means, see, if the same RDD I am taking, and there is a method called 2ds, there is a function called 2ds which will convert RDD to dataset. And once it is done, if I place the cursor here, you can see it is of dataset of string comma int. So friends, while checking the limitations, we have seen this one, right, cannot regenerate the domain object. So now what we have done, we have created an RDD, we have converted that to a data frame, and also we have seen the second way to convert that RDD to data frame, and also convert that to data set. So now what is the regenerate, the meaning of what we have seen in the PPT, right? So for that what I will do is, so now what I have done here, if you see, this RDD is converted to data frame now. Now if I convert it back, df.rdd, so this is the method used for converting data frame to RDD. You have a data frame, just give .rdd and this will become an RDD and you can use it like an RDD. But now if I place the cursor here, you can see the type of this RDD is RDD of row but not RDD of string comma int, which means that this is the standard, I mean the basic first type of the original type RDD type is RDD of string comma int. Once you convert that to data frame, it became the data frame, and now you are trying to convert that data frame to RDD, but now the type of that RDD is changed back to row. Okay, this is the disadvantage, I mean limitation of using the data frame. Like once you converted RDD to data frame, you cannot convert data frame back to the same domain object. The domain will be changed. Similar way, let's convert the data set. So this is the data set I have created, right? So for this data set, similarly I am doing ds.rdd, okay, and if I place the cursor here, you can clearly see RDD of string comma int means using the data set we are able to get back to the same domain object, which means that same type of the RDD, which is same as the original RDD type, which is RDD of string comma int. So you hope you clearly understood the meaning of this one. So now friends, here we have used Scala to see all these things. Now let's see the same using the PySpark. I am using Databricks Community Edition. So this is the way we can create RDD in PySpark. I mean, one of the ways to create the RDDs. We will see different ways in upcoming videos. So if you see here, using the parallelize method, I am creating one RDD, and RDD.collect I am using, and the output you can see it has been given. I am sorry, okay, I have to run this code also to show you, because yeah, I am doing run a Scala application. It is done. So first we are printing the RDD. So this is the way it will be there, because it's not a tabular column or something. This is RDD. And second one, we have used 2df, and we have given the names fruit and price. So because of that reason, it is giving the column headers for this one, and similarly this one we have created using the after the Spark implicits using 2df method, and this is the data set. So from the solution, or from the output perspective, there will not be any difference between all these things, but internal mechanism and these kind of, we just checked, right, like how the domain object will get regenerated here, but we cannot regenerate using the data frame. So such kind of methods will differ between RDD, data frame and data sets. So now let's discuss about the differences between RDD and data frame and data set. So from the initial version of Spark, like 0. whatever, right, 1.0 version, RDD was the first one which got released along with the first release of Spark, and then data frames are introduced in Spark 1.3 release, and data sets are introduced in Spark 1.6 release. Second one is meaning of this is that data representation is like whatever you spread across the cluster, all those the data is considered as Java objects, and for the data frame it will be considered as a table, and data set it's just extension of the data frame, but similar to data frame, it's like a table only. And coming to the formats, like RDDs can process unstructured, semi-structured and structured data, whereas data frames can be used only on top of semi-structured or structured data, and again data sets can be used in unstructured or semi-structured or structured data. And next difference is cannot infer the schema, which means that whatever the data that you are going to process, you have to explicitly mention the schema, then only RDD can infer the schema, otherwise it is not possible. Whereas data frame, there are some options like infer schema, it will automatically it will infer the schema, and you don't have to explicitly write a schema struct in most of the cases, like case class and all that. Most of the cases it's not required. It will, the Spark itself can manage to fetch the schema. And the data set, right, so it represents the data in the form of JVM objects of a row. So it will have some encoders to understand the schema, and it will automatically take it using the help of encoders. So that is the difference between these three. And coming to the different file formats, all the three can read any kind of file formats, and they can process any kind of data formats. And yeah, conversion RDD to data frame and the data frame to RDD is possible. We have seen that. And similarly from the data frame we cannot regenerate the RDD once moved to the data frame, that also we have seen. And RDD to data frame and data set is possible, and vice versa also possible, that also we have seen. And next one is provides compile time safety. Compile time safety means it will give the compile time errors but not the runtime errors. I mean whatever some errors, right, that will be given only during the runtime, but in the compile time it provides some errors in the compile time. And next one is attribute errors are shown during the runtime. As I said, if any table name or column names are wrong, that will be shown during the runtime only. But in the data set again, even the attribute errors that will be shown in the compile time itself. And coming to the optimization techniques, for RDDs there are no built-in optimizations. We have to make sure that to take all those things in the coding itself. But whereas data frame and data sets, they have the advantage of using the catalyst optimizers and tungsten optimization. Because of this only data sets, data frame and data sets are quicker than RDDs. And coming to the serialization, RDD uses Java serialization. Means whatever objects, right, everything will be converted to Java serializable objects and then it will process them. Whereas data frame uses Spark serialization, which means that any data frame that can serialize the data into some half heap storage in memory, because Spark is mainly used for in memory maintenance, right? So it will serialize the data into in memory storage in binary format, and then it will perform all the transformations, and then directly it will perform the in memory transformations. So because of that, Spark easily can understand the schema. So because of this, there is no need to use Java serialization to encode this data. And similarly, dataset also, it has some encoders to perform this. So because for this serialization, so even for the dataset also we don't require any external serialization. And coming to the garbage collection, from RDD we have overhead for garbage collection whenever we create or destroy some objects. So we have to take care using the code. And data frame, it will take it on its own. So we don't have to do anything for that. And same with dataset. And also in dataset, what is the main advantage compared to the others is this tungsten will take care of the serialization. So for the whatever off heap data serialization we have discussed, right, that will be done by tungsten. Because of that, it will not have any garbage at all, so it is very quicker than compared to the other two. And even if of course, right, because of the serialization will be there in only in RDD. RDD is slower and data frame and data set are faster when compared to these two, this RDD. And coming to the evaluation, all the three are lazily evaluated. And RDD can be written in Java, Scala, Python and R, and the same as data frame. Even data frames also can be implemented using Java, Python, Scala and R. But whereas data set, Python and R, right, they are dynamically typed languages. Because of that, data sets are it's not compatible to write. So because of that, we can write only using Scala and Java. And then aggregation, like for any aggregations, right, it's actually RDD API is slower to perform some grouping and aggregation operations, but whereas data frames and data sets are faster to do that. That's because it will go through the optimizers. Okay. And you can actually mention all these things, right? These are the main the differences between RDD, data frame and data set. I think these are enough to discuss in the interviews. And when to use what? So let's say When you want to do some you want to perform some low level transformations and actions on some data, in that case you can use RDDs. If you have some structured data, you wanted to perform some operations on table kind of, and you have to work with a hive, something like that. I mean, you have some structured data easily, I mean the schema is known or something like very tabular format kind of data you have, and column to column kind of operations you need to perform, then you can use data frames or data sets. And when you want to work in Python, then you cannot use data sets, so you can go ahead with data frames. Also, when you have some very unstructured data and it's very complicated to apply some schema to it, then you can use RDDs. And mainly sometimes what will happen is you have some functional programming to be applied, some methods from functional programming to be applied on some unstructured data or any kind of data, like more of a programming, then you can use RDDs. That will be quicker. And also, if you wanted to get the optimization, like you have some data which is very huge and you have to perform joins or something like that, I mean you have to apply a lot of Oracle, in the sense some joins, unions and calculations, applying the UDFs, all these things, then you can use data frames. If it is Scala, or you can use Python. If it is like data frames, you can, if it is Python, you can use data frames, or if it is data sets, you can use using Scala or Java. So in rest of the cases, right, it doesn't matter, like it's based on the data only we will decide with it's first and based on the data format and what kind of operations we need to do. So based on that we will decide which one to use. Okay, hope this is clear to you friends for answering the interviews. Thank you for watching the video. Please subscribe to my channel for more interesting learnings. Thank you.